In the last class towards the end, we got the results for the field in case of uniform thin spherical shell. It was a case of spherical symmetry, and therefore the field should have only radial component, and that is given by minus dou V by dou R. We already had the results for V. For example, for outside, we use the result. For outside point, we use the result, we differentiate it, and we got the result for ER. However, for inside points, the result used was the result which was valid for a solid sphere. So there is a correction here. The formula for potential at inside points for a shell is this. It is constant everywhere. So if you differentiate a constant thing, you get nothing. So for inside points, ER is 0. Please make this correction in your notes. What we discussed for internal points, the formula that we used, that was for a solid sphere, and that's what we are going to cover today, right now. Unless you have any questions regarding this, we move on to solid sphere case. There is no change for the outside points result. Looks like no questions. Here also we will have same argument. It's a uniform solid sphere, so whatever has to happen should happen radially. Now, ER is minus dou V by dou R. For outside, what is the formula for V? You know that. And therefore ER is Gm by R square. It's the same result for shell or for sphere and for point mass. For outside points, there is no difference among the point mass, the spherical shell uniform, the solid sphere uniform. There is no difference in these three for outside points. Now, for inside points, what discussion we had towards the end of the last class, that was valid for this inside. So the V that was used that V was minus gm by twice a cube 3a square minus r square. Now ER would be minus dou V by dou R taking constants out. Derivative of 3a square is 0. Minus r square minus 2r. So minus gm by a cube into r. I don't think it should be minus. Let me recheck. Okay, fine. This is vector actually. So there was no arrow. That's why some confusion. It's okay. Minus sign is showing that it is inside. That is, if we are finding E here, vector R is away, right side. But minus sign means it is towards the center. That's it. Magnitude if you take, there is no minus sign. Any questions? If you have, let me know. We discussed earlier that gravity due to acceleration g and field, they are actually mathematically equal. Conceptually they may be different, but mathematically they are equal. So in the context of Earth, the behavior of G should be similar, meaning if you watch outside the Earth, then ER is gm by r square. That means G should also fall as R increases. So if one goes higher and higher from the surface of the Earth, then distance from the center of the Earth, which is small r, increases and increases. And therefore ER decreases and decreases, and hence G decreases and decreases. Many times we are interested to know the variation of G with height, not small r, but it is height that makes more sense to us, more easy to deal with actually. Height above the Earth's surface. That theory we have yet to do, but the behavior can be seen right now. So if you are trying to know what is G at Moon due to Earth, then it's not 0 for sure. It is gm divided by distance between Earth and Moon square of that. So small g of Earth at Moon is not 0.